Today we're going to talk about determining if a given number is a solution to an equation, inequality, or systems of equations. A couple of key terms that we need to know. An expression is numbers, variables, and or operations, like addition, subtraction, multiplication, grouped together to show the value of something. You can't solve expressions. An equation, on the other hand, is two or more expressions connected by an equal sign. You can solve equations because they have an equal sign. When you solve, you're getting something equal to something else. An inequality is two or more expressions connected by an inequality symbol. You can solve inequalities also. Simplifying versus solving. When you simplify an expression, you make it simpler. That's what we've been doing in section 2, all of module 2. The variables in the equation can stand for any number that you want to put in. So when we were simplifying, say, x squared times x to the third, and we got x to the fifth, we could put any number in for x, and this will always be true. Solving, on the other hand, we're solving an equation. When you solve, you get a definite solution for the variable or variables in the equation. So, for instance, you'll have x equal 2 when you're done solving. When you're done solving and you have x equal 2, that's the only number that variable can be. Checking your answer. When you check your answer whenever you solve, because since you're getting a definite answer, you're able to check and make sure your solution is correct. To do this, which we'll be doing the rest of this section, is you substitute the solution you got into the original equation to see if your answer is true. So for instance, we have 7 parentheses x minus 6 equals negative 56. We're going to check and see if negative 8 is a solution. So we substitute negative 8 where x is. So we're going to have 7 times negative 8 minus 6, and we don't know yet if that's equal to negative 56, so let's go from here. 7 times negative 14, because we can do order of operations, negative 8 minus 6 is negative 14. 7 times negative 14 is negative 98. This does not equal negative 56, so it's x equals negative 8 is not a solution. Let's try negative 2 though. 7 times negative 2 minus 6. Again, order of operations, we get 7. Negative 2 minus 6 is negative 8. That's equal to 7 times negative 8 is negative 56. So x equals negative 2 is a solution, because negative 56 is equal to negative 56. Let's try it with absolute value. Now remember, we're going to treat absolute value like we would treat parentheses. So we're going to start with the absolute value of 4 times 7 minus 4. We're going to do what's in the absolute value first, like we would in parentheses. So 28 minus 4, the absolute value of 28 minus 4, that's equal to the absolute value of 24. The absolute value of 24 is 24, which is what we want it to equal. So this is x equals 7 is a solution. So let's check x equals negative 7. So we have the absolute value of 4 times negative 7 minus 4, which is equal to the absolute value of negative 28 minus 4. Negative 28 minus 4 is the absolute value of negative 32, which is positive 32. we want positive 24, so x equals negative 7 is not a solution. I'm going to abbreviate solution now. Now, for the next one, we have an ordered pair, and we have an x and y. So remember, the first letter of the ordered pair is x, the second letter is y. So we're going to put negative 6 where x is and negative 2 where y is. So 5 times negative 6 plus 3 times negative 2. Notice when I'm putting in a negative, I'm making sure to put it in parentheses so I remember to multiply it by the whole thing. So we have 5 times negative 6, that's negative 30, plus 3 times negative 2 is negative 6. Negative 30 plus a negative 6 is negative 36. So this one is not a solution. Because it's not equal to negative 4. Let's try 1 and negative 3. So we have 5 times 1 plus 3 times negative 3. That's equal to 5 plus negative 9. 5 plus negative 9 is equal to negative 4. So this is a solution, because negative 4 equals negative 4. That makes a true statement. Now we have inequalities. So we're going to say y equals negative 2, so we're going to put negative 2 where y is. 2 times negative 2 minus 4. So that's equal to negative 4 minus 4, which is negative 8. So then we have a question mark. Is negative 8 less than, because that's where our less than is, negative 16? Negative 8 is not less than negative 16, so it's not a solution. Let's try y equals negative 9. 2 times negative 9 minus 4 is equal to negative 18 minus 4, which is negative 22. Is that less than negative 16? Negative 22 is less than negative 16. That's true, so it is a solution. Now let's try negative 6. 2 times negative 6 minus 4. That's equal to negative 12 minus 4, which is negative 16. And our question is that less than negative 16? That is not less than negative 16. It equals negative 16. So this is not a solution. If, on the other hand, this is just an if, this is not what it's written, but if this was less than or equal to, this would be less than or equal to, so then it would be a solution. So when they're equal to each other, you have to make sure it's an equal to inequality, not a strict inequality. Now we're going to find out if something's a solution to a system of equations. To be a solution to a system, the solution has to be true in both equations. So let's try 6 and negative 3. So we're going to put 6 and negative 3 in the first equation, and then we're going to put 6 and negative 3 in the second equation. So 4 times 6 minus 7 times negative 3 is 24 plus 21. Negative 7 times negative 3 is positive 21. That's equal to 45. So this is not equal to negative 8, so right away we know this is not a solution, because right away it's not equal to. Let's try 5 and 4 in the first equation. We have 4 times 5 minus 7 times 4. So that's 20 minus 28. That equals negative 8. So that one checked out. So let's try it in the second one. 3 times 5 plus 2 times 4. That's equal to 15 plus 8, which is 23. 23 is not equal to negative 6, so even though it worked in the first equation, it's not a solution because it didn't work in the second equation. So let's try negative 2, 0. So we have 4 times negative 2 minus 7 times 0. So that's negative 8 minus 0, so that's negative 8. So that one checked out. And then 3 times negative 2 plus 2 times 0 equals negative 6 plus 0, which is negative 6. So that one checked out. So this is a solution. So negative 2, 0 is the solution to that system of equations. Now, just because it's a fraction doesn't mean we don't know how to do this. So let's try y equals 11 over 8. We want it to equal 8, but we're going to start with this side. So we have negative 5 over 11 over 8. I'll erase for the next solution, minus 2. Using our complex fraction rules, we're going to add the denominator first. So that's negative 5 over 11 over 8 minus 16 over 8. Remember how to find an equivalent fraction. So that's negative 5 over negative 5 over 8. Complex fractions, we multiply by the reciprocal. So that's negative 5 times negative 8 over 5. The negative times negative is positive, and the 5's divide out, so we get positive 8. So that checked out. So this is a solution. 11 over 8, y equals 11 over 8 is a solution. Let's try. If you need to rewind or pause, go ahead. I'm going to erase all the ink. Y equals 2. So we have negative 5 over 2 minus 2. So that's negative 5 over 0. We can't divide by 0. So it's not a solution. So if you get 0 in a denominator, it's not a solution. Just keep going in your workbook. You can do the radical equations. Just plug the numbers in and see if it equals both sides. If both sides are equal. If you're in Math 94, skip 7 and 8. If you're in Math 105, try 7 and 8. We will talk about logarithms soon, so don't get too flustered when you try them. That's it for today. See you tomorrow.